As I had mentioned before, when it comes to female reproduction and the reproductive system, it's more complex. It's more intertwined. It's not as cut and dry as males. We were able to take a look at each thing individually. Spermatogenesis, hormones, anatomy. Not so much when it comes to females. So I'm going to have to try and run a number of things essentially together, talk about a few things all at one time. Just to give you a taste of how much more complex the female animal is, I want to look at what's called oogenesis, the origin of the egg. Where does it come from? Now with this, ignore what's up at the top. Ignore the oogonium through oogonia. This is stuff that happened when you were in utero, when you were developing as an individual. But take a look at this down here. We've got meiosis 1 and we've got meiosis 2. There are a couple of things that are very different than males. Remember, with males, what we do is we end up with 4 essentially identical, as far as anatomically or morphologically identical gametes down at the bottom. Something weird has happened here. There are different sizes, and we see different sizes down here again. Now I wish they had continued on with this image like this. And what we see is this, because Dad literally physically only contributed 23 chromosomes. No cytoplasm, no organelles, nothing else. It all now falls in Mom's lap. So Mom can't divide up her cytoplasm and cellular components into quarters and then allow 3 of them to just go away and waste 75% of what she has to offer. So what she does is she does cytokinesis. She does telophase, where we split into 2, which typically is identical. What goes here goes here. It's different. So really, when cytokinesis happens, it effectively happens like here. And so it still occurs, so everything that you know about meiosis still holds true, but now we have this little tiny bit that's kicked off and everything else is retained. These down here are called polar bodies and will do nothing. They'll die. There's not enough cytoplasm to keep them going. This is the egg. This is what we want to go for. This is the gold standard when it comes to the female reproductive system. So you might go, okay, well, that seems like I can get it. I have another twist to throw at you, and it's this. Maybe some of you have heard, there's a line right there. Maybe some of you have heard, oh yeah, you know, every female is born with about 200,000 eggs. That's wrong. She's not born with any eggs. The reason is this. During this process of oogenesis, those cells lock up. In other words, that primary oocyte locks up in the middle of meiosis in what is called prophase arrest. So it goes into prophase, and that's as far as it goes. So you're born with, or a female who's born with 200,000 primary oocytes, that's a rough guess, and they're all stuck in prophase arrest. Now, if you're scratching your head, we've got to get all the way around to fertilization before we get out of that arrest. So that's where we'll be in the next 1 or 2 videos. So that's what we're shooting for. Now, once you've got this cell that is stuck in prophase arrest, it can't do its job. It can't take care of itself, it can't metabolize. So if you think back to the nervous system, neurons had cells that took care of them, astrocytes, glial cells, Schwann cells. We find the same thing here. So our primary oocyte looks like this. And then we have a series of cells around it take care of it. And what those cells are called are follicle cells. This might ring a bell from FSH with males in puberty. And this entire thing, this collection of one primary oocyte surrounded by follicle cells, is called a follicle. What a typical human female is born with is about 200,000 follicles. And they look like that. So I can see the oocyte and the follicle cells around the outside. Oocyte, follicle cells around the outside. So now we've got to figure out, well, how do we go through the progression? How do we get from being a follicle and a primary oocyte in a follicle to becoming the egg, the ovum, for fertilization to take place? This is where we really can't do this in a compartmentalized way. We have to throw everything together here, hormones, anatomy, and this is what makes it a little bit more complex. So I want to look at a standard, I want to try and put all this together somehow through a standard, a routine ovarian cycle. And I'm scratching for the right word because the ovarian cycle that I want to take a look at is 28 days long. That's your standard, it's your typical. But some of you that are female that are watching this might say, hey, whoa, wait, my ovarian cycle is 30 days, 32, 25. Okay, that's fine. Your level of activity, body fat content, diet, all sorts of things can vary it. And some of you might say, well, mine varies from month to month. Yeah, that's fine. I just want to go the standard 28 day. There are three essentially benchmarks that I want to look at. Day 1, day 14, and day 28. And I want to take a look at what happens hormonally and in the ovaries during each one of these phases. The first phase is called the follicular phase because it's all about the follicles. We're going to do a lot with follicles. The second 2 weeks is referred to as the luteal phase. And you probably can't make an association with that yet, that's fine. We're going to figure out where that term comes from. So I'm going to walk my way through the hormones, then I'm going to go back and I'll try and do both of these things at the same time. Let me take a look at day 1. Day 1, the anterior pituitary, that little bean that hangs off the base of the brain. We addressed this when we talked about male hormones, especially going into puberty. The anterior pituitary is now going to cause a hormone called FSH, or follicle stimulating hormone. We've already talked about it, to shoot up. What FSH is going to do is ideally it's going to stimulate and what we call mature one follicle. Which ovary? Don't know. Which follicle? Don't know. But one of them is now going to be stimulated. And what that means is that the follicle cells are going to start to go through mitosis. So this follicle is going to get bigger and bigger and bigger and bigger and bigger. Now, those follicle cells take on a role of their own. What they're going to do, and if I had more time, I'd go into this in depth. Maybe these follicle cells have been taking care of this primary oocyte for 29 years. They don't want any other follicles to be stimulated. It's their time to shine, in essence. So they're one of the 200,000 that was randomly chosen. So what they do, the follicle cells, is they start to kick out estrogen. So suddenly, a female's estrogen will spike. Now, why? Well, here's what the estrogen does. The estrogen talks back to the anterior pituitary. And the estrogen tells the anterior pituitary, hey, knock it down with the FSH. So you're the only one. There's no more FSH flooding these ovaries. 2, it tells the anterior pituitary, kick up the level of LH, luteinizing hormone. Another one that we talked about with males in puberty. So once estrogen is secreted from the follicle cells, or what this is calling follicular cells, estrogen goes up, well, it makes sense. FSH comes down, LH goes up. Now, let me jump to the next slide. We'll come back and revisit this one in a minute. Here's what's essentially happening. Here's the follicle, here's the follicle, here's the follicle. And you can see the follicle cells get more numerous, they get more abundant. And all of a sudden it gets to the point where this area inside called an antrum starts to form. And I've got that, I think, 2 slides down, so I'll have this spelling. What LH does, luteinizing hormone does, is it increases the pressure inside this. So it increases the amount of fluid, so it increases the amount of pressure. And this is what we refer to as a Graafian follicle. It's this. So here we've got the wannabe egg, that primary oocyte. These are all follicle cells. This is all antrum, it's all fluid. What we want to have happen is the pressure get high enough that it actually bursts. And when it bursts, what's going to happen is we're going to get this primary oocyte that leaves. That primary oocyte that leaves is going to be literally physically burst out of the side of the ovary. This is a standard variation on what you see in a lot of textbooks. It's a time lapse. So these arrows don't mean that this structure is migrating through. It means this is what happens as time progresses. Here we've got our follicle, more follicle cells due to the FSH. We have our antrum start to form. Here's our mature Graafian. The LH is kicking up, and we end up with the primary oocyte being released from the side on day 14. Day 14 is the time, the day of ovulation. I'll show you what this looks like, hopefully before we're done with this video. Now, if you follow this, all of a sudden we have this thing that looks like a wad of chewing gum. Well, this is known as the corpus luteum, or some people will refer to it as the corpus luteum. Either works. What this is all of the remaining follicle cells. Some of the follicle cells left with the oocyte, the rest of them stayed, and they now become the corpus luteum. This corpus luteum is why these last 14 days are referred to as the luteal phase. So what's the corpus luteum do? Here's what it does. It secretes a hormone. It's the hormone known as progesterone. So suddenly progesterone shoots up on day 14. Progesterone is going to keep LH low and FSH low, because now you've done it. You've successfully ovulated that oocyte. You don't want any more stimulation of follicles to happen in the ovaries. Now, what will slowly happen? Let's suppose there's not fertilization. Here's what takes place. This is going to careen down the oviduct, just so you can see what we are dealing with for real. All of this becomes the corpus luteum. And as it works its way down the oviduct, it wants to make sure that there's nothing else that's stimulated. But slowly the corpus luteum will die. And I'll get around to this in a couple. As the corpus luteum dies, which will take about 2 weeks, the amount of progesterone goes down. If the amount of progesterone goes down, the FSH goes back up. So then we get back to day 1. So let me walk through this one more time. Day 1, follicular phase. Anterior pituitary causes FSH to spike. That matures a follicle. The follicle cells, now that they're active, are going to secrete estrogen. Estrogen will keep the FSH low now and kick the LH up. The LH goes up, the pressure in the antrum of the Graafian follicle goes up, ovulation takes place. So here's the ovary over here, and this is bursting out of the side. Now what we're left with in here, the cells, the follicle cells that are staying, they become the corpus luteum. They kick out progesterone. Progesterone sends the signal to keep LH and FSH down until the corpus luteum slowly dies. Then the progesterone levels go down, FSH goes back up, mature another follicle. I won't waste your time going through that one more time. This is essentially what we're dealing with. We'll look at the idea of what happens, what goes on if there is fertilization in another video or two. But this is the gold standard. This is what we're going for. And over here on the left-hand side is the oviduct or the uterine tube. And if you look, sperm go directly from the seminiferous tubules right into the urethra and out the penis. We have this gap. So females have to take their gamete and kind of allow it to course across this gap and get picked up in the uterine tubes, the fallopian tubes, or the oviduct. I prefer oviduct just because it implies egg. It's the egg tube. So here's that same little time lapse. There's the ovulation, and then we have to find out what goes on up here. But we also have to address what's the rest of this anatomy that we're looking at. So we have a ways to go. So let me switch this over and cue up